And so that's all the housekeeping. And now if I could welcome up our 4 panelists, and once they've got them all seated here, I'll introduce you to them. Come on up, all 4 of you, and then we will go straight into the presentations. First of all, it's my great pleasure to introduce on the far side of the stage from me, Jeff Vickers, who's the Technical Director of ThinkStep in New Zealand. And Jeff's been embedding sustainable thinking within organizations for well over a decade and working across sustainability assessment, strategy and innovation in very complex life cycle businesses, such as in the building and agriculture, transport and electronic sectors. And he's worked with such organisations as Fletcher Building, New Zealand Steel, Downer, Lend-Lease and the European Commission. So a big hand for Jeff, please. Thank you very much indeed. Next to Jeff is Helen Jenkins, who's General Manager of Sustainability at Fletcher Building. Helen's is a sustainability professional specialising in carbon reduction, particularly in infrastructure and the building materials sector, and as a very strong advocate for embedding carbon reduction initiatives within existing strategies. So over the last 10 years, Helen's worked across a number of sectors such as road, rail and utilities for companies or organisations such as Network Rail and Anglian Water in the UK and Auckland Airport here in New Zealand, and of course now at Fletcher Building. So a big hand for Helen, please. Thank you. And next to Helen is Sean Macisaac, who's the Director and Senior Building Enclosure Engineer at Oculus Architectural Engineering. So a specialist, of course, in enclosures, whether they be windows, walls and roofs of buildings of all types. Sean has very wide experience and that he has been putting to great use here in New Zealand since 2016. So a big hand for Sean, please. Thank you very much indeed. You might have spotted his T-shirt, Make Less CO2. I'm not sure it has quite the same ring as Make Peace, Not War, or Make Love, Not War, but maybe we'll get there on our journey. Not tonight, it's a longer-term project. And then next to Sean, it's my great pleasure to welcome Sally Gray, who at Auckland Council is the manager of Premium Building Consents. Sally came to building consents through managing the weathertight litigation issues for a very good few years, and before that was an in-house legal counsel for several Auckland companies. So she's been very deeply involved in how much work it is to put things right after they've gone wrong. And I'm sure that very much shapes her thinking these days about how to build right from the very beginning. So a very big hand for Sally, please. Thank you very much indeed. So I'm going to hand straight over to Jeff. I'm going to nip into his seat rather than loiter by the door here. So over to you, Jeff. Thanks very much indeed.
Thank you, Rob, for the kind introduction. Is this on? Yeah, great. So kia ora koutou. Tonight I want to talk to you about a couple of public reports that we've recently released. So ThinkStep as an organisation works to help companies and other organisations succeed sustainably. And one of the key ways we do that through is trying to work out what matters. So we use a tool called life cycle assessment and materiality assessment to try and work out where some of the big hotspots are and then to identify strategies to reduce them. So in the last sort of year and a half, we've released 2 public reports on the built environment. The first one was focused on quantifying kind of the significance of the built environment to the carbon footprint of New Zealand. And that's where you sometimes hear this 20% number being quoted. That comes from one of our early reports, and I'll kind of get to that in a moment. And the next report I want to talk about is one called Under Construction, which was released last month, and sort of demonstrates the potential for building products and building materials to be decarbonised, looking at it from a supply side. So I'm going to probably try and dance around a little bit while I talk. I hope it doesn't make any of you dizzy, but it gives me something to do with my feet. Okay, so what I want to do first is just sort of highlight some of the context for our work. So back in 2016, 2017, there were a series of reports released on New Zealand's carbon footprint at a national level. And there was one well-known one by the Royal Society, one by Globe New Zealand, and another one by the Productivity Commission, the first part of that being their issues paper. And those reports talked about the built environment, but because their focus was very much on what we produce as a nation, they were really focused on energy generation, for example, and this big, bold category of industry which produces all of our stuff, which goes into lots of different places. And so what those reports commonly said is that the built environment contributes sort of 2% or maybe 5% or maybe 8% of our carbon footprint, looking at energy only. But it was very focused on operational emissions. It didn't look at, and deliberately so, didn't look at the impact of making materials. Those emissions that we would refer to as embodied emissions or upfront emissions, those things that are typically hidden, involved in making the materials, whether that's steel or concrete or the cement used to make the concrete or the timber products that we use or whatever it happens to be. So those embodied or upfront emissions are what we wanted to investigate in a bit more detail. And so in 2017, 2018, we started trying to quantify what those emissions were and separating them out from these big groups of, energy, industry, waste management. And so the first thing that you see here is, this is the kind of traditional view. This is New Zealand's greenhouse gas inventory. You can see a big number there for energy, and of that, about 5% of the total number comes from the built environment. But if you look at that in a different way and you consider what we consume as individuals, not what we produce, so we also account for the carbon embodied in trade, the things that we import that we don't make, and that's across the board, not just in buildings, but also importing cars and textiles, for example, and the fact that as we as New Zealanders and we as a nation are a net exporter of carbon through our agricultural products in particular, exporting dairy products, exporting beef and lamb, etc. Those products we export about 90% by value. So what happens when you look at things in terms of what we consume, where we've got an ability to change it as a consumer or as a business, our carbon footprint as a nation shrinks. So you can see it goes from about 17 tonnes of carbon dioxide equivalent, a very sexy unit I know, down to 13 tonnes. And what you can see is a complete shift in how things sort of stack up. So all of a sudden, the built environment, rather than being this kind of token 5% within energy use, and then kind of some part of industry that we can't quantify, it becomes about 20% of our carbon footprint because the whole carbon footprint shrinks, and we're focused more on what we're using. And if you break that down even further, where does that 20% come from? A big chunk of it is actually from materials. And I need to caveat that it's also the materials used in infrastructure. So it's infrastructure and buildings, but you can see these big numbers here, materials and also imported emissions in terms of things that we bring into this country that we don't make ourselves. And some of those things are professional services and things too. It's not just materials, but some of that is certainly the materials themselves. So what this shows is that in New Zealand, in our local context, embodied emissions, the upfront stuff, the stuff that's built into the buildings before you even get into them, those kind of hidden emissions, those matter in New Zealand. They really, really matter. And there, in this report, it was about 50%. In specific buildings, it's not that high. Maybe it's 30% or whatever. But the point is that they really matter in the New Zealand context because our energy mix is already quite clean. We've already decarbonised our energy mix to a large extent. It was already quite low carbon. We use a lot of hydro, a lot of wind, geothermal. We are a little bit unlike other countries who are still using a lot of fossil fuels to produce their electricity. And so that makes the New Zealand context a bit different, and it means we're a little bit further ahead on the embodied emissions game, because for us, it's more relevant already right now, and importantly, those emissions are being emitted now, whereas the emissions across the building's life are being emitted over a whole period of time. The building might last 60 years or 90 years, whereas the embodied emissions are mostly happening now when the thing gets built. And so what can we do about it? Well, we looked at another piece of work that we released last month. It's titled Under Construction, and we showed that we can reduce those emissions by 40% by 2050 by producing our building materials in a smarter way. If you look at where the hotspots are in terms of the built environment, the big ticket items are things like concrete, steel, aluminium, and certain other materials also pop up depending on the context, like paint and plasterboard and other things. But those materials, as well as in certain contexts, timber, are very significant from a carbon footprint perspective. And so we can reduce that by 40% if we design our materials and building products in the right way, if we change the way we manufacture things, and if we decarbonise the production of materials. And this is very much a supply side focus, but if we also work on consumption and sort of a demand side and build buildings in a better way, use fewer materials to start with, focus on choosing the right materials, then we can have a kind of win twice situation where the materials to begin with are really low carbon, but we're also using fewer of them. So two of the points that the report highlighted which aren't shown here are really the need for collaboration and for innovation. Innovation to drive down the impact of materials, but collaboration throughout the entire supply chain to really encourage the uptake of them. Because if no one's demanding them, they won't be produced. And if specifiers aren't specifying them, they won't be produced. And if building product manufacturers don't have long-term supply contracts in place, perhaps, for example, they can't justify the investment to overhaul their manufacturing equipment, for example, when they also have to compete with imported product. And so I think, collaboration and innovation are two things that have to go hand in hand to achieve these kinds of reductions. And that saving of 40% in the embodied emissions is equivalent to about 500,000 cars off the road permanently. Because we're building these buildings every year, we can take the equivalent of about 500,000 cars off the road if we go down this path. Finally, I just wanted to put a link to the report up there. You can download it if you're interested. You can also download our earlier report and find out a little bit more about how we can potentially decarbonise New Zealand's built environment together. So thank you very much.
Thanks. Thank you very much indeed, Jeff, for stepping us through that. And those are certainly very encouraging targets for us to go for in the coming years. Excuse me, over to you, Helen. A big hand for Helen, please. Thank you very much indeed.
Good evening, everyone. Kia ora tātou. So I'm going to pick up on some themes that may become the themes of the evening, actually. Thinking about where we could make some big shifts in the actual production of building materials. There's an aspect of making what we build buildings out of more sustainable, and there's also a need to look at what are the kind of shifts we need in the construction industry itself. So one of the areas we really need to focus on is lower carbon materials, more sustainable materials, lower carbon materials. And as Jeff pointed out, the carbon that's locked inside building materials can be a little bit hidden. So a really big lever to get to more sustainable materials is actually doing a life cycle assessment of, what you're manufacturing that then goes into a building. And it's certainly, with Fletcher Building, it's a huge focus for us to have environmental product declarations that actually identify that. And in fact, starting with the difficult end of things. So we have those in place already for our cement, insulation, wallboards products, and some of our steel products. But really intend to roll EPDs out for the entire product line that we make, because they do two really important things. One is that they would point to the areas where you are having an impact and therefore can improve internally as a manufacturer. But secondarily, and I think more importantly, and this is why I'm a huge advocate for doing this more widely within the industry, if you really know the impact of a building product, when you're at that early design stage and you have the opportunity to optioneer, you have the opportunity to choose a different range of materials, it's only that life cycle analysis of the materials that you're choosing that will let you make a decision that's genuinely better in terms of design. And that leads us on to another point that Jeff made, which is that the better materials part of the problem, it does need innovation, and we need innovation with an agility of building specification and standards that allows for that innovation, but we absolutely need to maintain technical and quality standards for building. So those two things really have to work in tandem. Also, in terms of the kinds of shifts that could be made in the wider industry, there's another part of the puzzle that fits into better materials and better design, which is looking at doing more design up front, so more 3D design, designing something in the virtual world before you design it in the real world. Gives you much more scope to optioneer for better products if you're building something digitally than if you're building it physically. It's cheaper and it's faster. So making more use of 3D design is an area where New Zealand really can expand. And then flowing on from that also is other ways of constructing. So making more use of modular construction, by which I mean sort of building entire components of the building off-site in a manufacturing kind of environment, where you get a very, very good, consistent standard of quality, and also you get the benefits of generally using far lower materials used per build than building when you build on site. So there are two very powerful levers we can use: design it digitally, and build it off-site to the extent that that's possible. But all of those parts of the picture, so having better and more sustainable, lower carbon materials, having smarter design, more optioneered design, and then making more use of the most recent construction materials, that really requires collaboration across the whole of the construction industry, designers and specifiers and constructors and end clients. And it's really that I guess that shared vision, those shared targets, and the collaboration that is what we need to make the shift that we all want to see, and actually to get the outcomes that we all want to see, to get our 40% by 2050. So I guess we're here because, as an organisation, and I'm here personally because I'm very excited by the opportunity to be part of that shift. As some of you will know, we're in the process of getting our science-based target verified. That's a 30% reduction by 2030, a 50% reduction by 2050. And also very core to what we want to do as a building products company is look at the life cycle analysis of what we sell. So try and be part of that collaboration and part of that journey.
Thank you very much indeed, Helen, for suggesting some very powerful pathways by which we might be able to progress these issues. And now I hand over to Sean. A very big hand for Sean, please. Thank you very much indeed.
Hi, everyone. Hi, people at home. I want to talk about the crisis happening in front of us. It's ignoring science, and it goes beyond just climate. It's kind of everywhere through our culture right now. And I don't know why that is. It seems that recently there's been more and more of it happening. We see it every single day. I'm an engineer, so I get to look at science, I get to look at products, I get to make evaluations based on science and physics. And then I go to a design meeting and suggest a product, and the first question I get asked is, has it been used in New Zealand before? I don't really understand why that happens. I think it's a fear. I think it's a little bit of trying to direct blame elsewhere. It's trying to keep your hands off of the pie, so to speak. But I think if we don't stop that kind of mentality, we're just going to be stuck where we're at. We've got scientists telling us we need to. You're not a scientist, Jeff, are you? Yeah, so Jeff's got some scientists that work for him probably. They're telling us we need lower carbon products. We need to build with less carbon. We've got Helen's companies building lower carbon products. We've got those to use. Then I've got to go and convince Auckland Council that new product that we've got is going to be fit for purpose, maybe for the first time it's ever been used before. So until we start to change this mentality of questioning things that has to have 10 years of track record to be used, we're just going to be stuck doing the same thing we've been doing for the last few decades. We've got a wonderful research branch, actually. Brands does some amazing science and research. And for as much flack as I give them, they actually do have a lot of really good things coming out of there. The really big problem is it's been around for 30 years, and a lot of the research is a footnote at the bottom of a policy paper that happens 20 years later. So I think we need to start listening to the science. We need to start looking for solutions that have track records from overseas that we can borrow. We need to start adopting those ideas. it's not a very big country, guys. I come from Canada, so it's not a very big country. Lovely country, I love it. But if we're going to do this in a rapid, sustainable fashion, very, very quickly, we've got things we can borrow, we can bring in, and then people like myself that can evaluate it and explain it to council and get building consents. That's all I had to open with. Looking forward to questions from everyone. I see there's lots of questions coming in, so thank you very much.
Thank you very much indeed, Sean, for getting us going on that, particularly from your perspective as someone designing buildings and using materials, and a very good point there about brands. And on to Sally, please. A very big hand for Sally. Thank you very much indeed.
Thank you. I have a few notes because unlike my fellow panellists, I don't work in this area all the time, and I wanted to keep on track and provide information of interest, and it's a privilege to be on the stage with you all. I made some notes during the week of what I wanted to say, and then I read the newsroom article yesterday on the Green Building Council report, and I thought, job done. It really covered everything that I thought needed to be said from me. For those of you who haven't read it, it made a call for an amendment to the building code as a primary tool for change. I agree. It called to introduce building energy labels. I agree. And it called for market action. And for that, I agree too. As most of you are aware, that Auckland Council as a building consent authority operates under the Building Act and the building code that's contained within regulation. We receive, we assess, we approve, we inspect and we certify building work against the building code. When I look through the Building Act, the purpose makes reference to sustainability. It mentions ensuring buildings are designed, constructed and able to be used in ways to promote sustainable development. Cool. And it's also mentioned in the principles in section 4. But there's no mechanism for us to actually enforce that. So it means if we receive an application that demonstrates compliance against the relevant clauses in the building code, we have to approve it. It may contain nothing about sustainability. It may have the worst polluting products. But as a building consent authority, we go tick. So I think if we want to change, we have to change those regulatory settings. From a synchronicity of timing, earlier this year, MB released a consultation paper that covered 5 key areas of building reform. I was at a talk recently where Minister Salisa indicated that the amount of work to deliver on all 5 key areas was enormous, and they were likely to be prioritising 2 for more immediate delivery, and one of those was modern methods of construction. So I could see some real synchronicity in what we all want to see happen. When I read through both the consultation paper and the feedback summary, there's not a lot around sustainability, to be honest. It's very much focused on durability and safety. And on the back end of decades or more of leaky buildings, I can understand that focus. But it does strike me that it's the ideal time to really be promoting these more sustainable principles into the construction of our buildings. In terms of opportunity, Auckland Council approves more than 20,000 building consents every year. This year we will exceed 24,000, of which 14,000 will be new builds. So to me that is, lots of potential. I spoke to one of our we have a number of high volume building developers in Auckland, and I spoke to one of them to understand what might be some of the barriers to driving more sustainability in the buildings they build outside of legislative change. And the feedback to me was that consumers are very price sensitive. There's a lot of interest in sustainability and how it is built and how it's designed for future reduced environmental impact, but there's no appetite to pay for it. So it struck me that timber and concrete and steel may not be glamorous enough, and the money is really put into those more glamour products like bench tops and bathrooms. And that's where I think the legislative change is, we need it to make that kind of consumer difference. I would say if you are a manufacturer or an importer and you are manufacturing or importing a product that has a better environmental footprint than something on the market already, don't lose sight that you should be investing in ensuring it's tested to the appropriate standard, it is appraised or it's certified, because that makes it a lot easier for designers to specify. It also makes it a lot easier for us as a building consenting authority to approve. Now, to probably preempt a question that might come through, can we prioritise some work over other work? Of course we can. Auckland currently has approximately 45,000 houses fewer than we need, and currently that's our priority. Council has a multi-faced role, I guess you could say. I know I've got some colleagues from our waste team here, which is one aspect. Council's also an owner of many buildings, and I've been advised that this next year we will set a green asset standard for council and community facilities, and we will track and report infrastructure carbon as part of Auckland Council's emission inventory. Council also gets involved in policy development and has a stewardship role for both the development and support for communities. And one key role we can do to deliver that for Auckland is to encourage growth, both in a compact nature and near public hubs, public transport hubs, to get people out of their private cars. Now, I want to finish on two random observations. While Auckland is becoming, to a degree, self-regulating in the size of houses it's building because of the price, the average size alone for a standalone house in New Zealand over the last 17 years, every year has been over 200 square metres, and for 10 of those 17 years has been 230 square metres or more. And it kind of begs the question, if we are serious about carbon and carbon emissions and reducing them, is that okay? And my second observation is the New Zealand Building Code only requires joinery and facades to be designed and manufactured to last for 15 years, and for structural elements to last for 50. Is that okay?
Oh, fine, thank you very much indeed. Thank you for making some very pertinent judgments and observations there, and putting out that incredibly important point at the end there about the very short time frame that we are designed and building or creating products for, that whether it be 15 years or the 50 years for the structural elements. Let me just start actually at that point across the panel. Is there good evidence that shows the economic value of designing and buildings and creating products that have a longer life than we are currently tending to build in New Zealand? Any takers on that?
You can ask Auckland Council what they think about that. Listen, if you build a building and have to rebuild it 10 years later, you're using twice the carbon. You're using twice the amount of money to build that thing again. And maybe you build it wrong the second time and you're rebuilding it the third time. The most sustainable thing you can do is build a building that lasts a long time.
Yeah. Any other Jeff, from your perspective and the sort of analysis you do?
Yeah, I don't know if I can always comment on a cost from a cost perspective, but certainly it seems that building it frequently would be very expensive. I mean, also from my experience as well, is that if you design, say, a roofing material or a cladding material, particularly for a multi-storey building, and you make that perform poorly, and so that it needs to be replaced regularly, health and safety regulation is the way it is now. It's actually incredibly expensive to go up there and replace a roof, for example, because you have to have all the scaffolding in place, all the cranes, everything's set up. And it's a very expensive exercise. So certainly from a life cycle, environmental life cycle assessment perspective, it makes sense to design things that last. But certainly also, I would say, not to make them last necessarily indefinitely, because we know that buildings do get pulled down, so we don't want to make things that last too much longer than they need to last. So in the New Zealand context, a house typically lasts about 90 years and a commercial building about 60. So there's no point designing a commercial building that's going to last for 500 years, potentially, because it might not be fit for purpose and you've kind of over-engineered it as well. So I think there's a balance to find there, but I would say certainly 50 years for structural materials and 15 years for cladding is far below what our buildings are currently being turned over, at the rate they're being turned over at. So that sounds very problematic from a, building perspective. Yeah.
Off the top of the head, do any of you on the panel have any international perspective on that in terms of the sort of expectations in other countries about longevity of materials and structures? Any sense of that?
Certainly not from the point of view of standards and specifications, but in both commercial building and infrastructure, there are two international movements which are relevant to this. One is design for deconstruction, which is, I would say, arguably not necessarily the place to start, but at least it's looking at the end of life fate of that building if it is rebuilt. But I think the other, and again, this is only a part of the question that we're asking, there's also a look at, particularly in terms of structural and foundational elements, the ability to test and reuse existing foundations. And this is in areas of the world where there's very, very dense urban environments, so it's not necessarily as relevant to New Zealand. But the thinking that rather than assuming you have to design everything, including the structural elements of a building from scratch, there's a movement to say, are there ways that you can incorporate testing, fit-for-purpose testing for those foundational elements and reuse them for another building that goes on top. I suppose one thing I would add that's a little bit further to Jeff's point is that I think it's certainly talking about the building fabric, absolutely longer design life seems advantageous. We generally, because of the efficiency of the systems within the building, there are potentially earlier breakpoints where it would make sense to upgrade those for energy efficiency reasons.
Thank you. There's actually a related question here on Slido. So thank you for your questions on Slido. Please keep them coming. And the question is, should retrofitting old/historic buildings be given more carbon credits than building new with all new materials? With all due respect to the question of carbon credits is a problematic one. In terms of a mechanism for doing that, but the sense of the question, though, is a really important one, that should there be virtue rewarded for retrofitting and using existing buildings?
I mean, from my perspective, there's certainly value in retrofit, but you don't want to go too far. There's always things that are more cost effective. It's very cost effective to do ceiling insulation, for example, and underfloor insulation in older buildings, whereas to do wall insulation, you have to remove all the cladding and things first, or remove the internal wall coverings. And so I think it all depends on the type of building. I live in an old house built in 1904. I'm never going to make that as airtight as a new building, and so I want to stay in that house because I really like it. But at the same time, building new would actually give you much more opportunity to make that building much more airtight. You're just never going to achieve quite the same results with retrofit. So I think to an extent it makes sense to prioritise, but I think there has to be kind of cut-off points where you say this far is far enough. At least that's my perspective.
So I'll respectfully disagree. We've got some good examples of retrofits that have achieved passive house standards, which have achieved very high levels of performance. When you look at the cost of, let's say you've got an existing window that you want to replace, if you look at the whole capital cost of that window, the payback period is very poor. However, if you're replacing that cladding or that window because of another reason, like it's a leaky building, your opportunity to go back with a higher performing product, you look at the incremental cost of going from a base building code product to something higher spec, that actually has a decent payback period. That's something we can actually calculate, and it's probably less than 10 years. So we've done a number of projects in Canada that have 7-year payback by spending 10, 20, 30% more during that retrofit process, and just being smarter about how we apply those products. So, exactly right, though, just doing it for a pure energy perspective doesn't make a lot of sense. But to your point, when there is the opportunity to replace that element, going to the next level, it makes a lot of sense.
And I would agree with that. If you're retrofitting anyway, put put in the best stuff you can. You know, if you have to replace the cladding, put in the best insulation you can, because it costs very little and it has a massive difference. I agree with that.
Thanks. There's in my own mind, there's a related question down the bottom here. I'm sorry that the screen you've got in front of you is a bit too small. But it's about incentives. That was looking at old buildings. But so this question is, will zero carbon buildings be given favourable treatment with council, i.e. free processing services to create incentives to the public to shift their choices? Is that a subject that's ever come up in discussions, Sally?
We have many people who would quite like free building consents.
Let me take that question elsewhere in the panel. Would that be a useful incentive?
I can tell you without a doubt that our company will give you a much lower fee if you are targeting a better building. Right now, you've got about 3 days left. We're offering to do passive house certification on large projects for 50% of the fee we'd normally charge you. And we've had a number of people jump on that option. It doesn't cost a lot less. So there are a number of designers, there are builders, there are engineers, there are people out there that if you are a client and you want to do something better, you will be rewarded for that in the fees. So I can't help council. They don't have much power either, but there are certainly people in the industry that are very interested in helping you.
Thank you. Let me move on to some materials question. There was a very interesting one which has now dropped off the screen because at that point it only had one vote, but I'm going to go to it anyway. Oh, there it is. Oh, it's now got 8 votes. From Jerome. Firth concrete has lower embodied carbon than any other concrete globally. How can it reduce it more? Firth is a Fletcher company, isn't it? Can you tell us about that very low carbon concrete and how that happens?
Yes. I won't dive into the technical details. I guess the fundamental difficulty with the cement and concrete, which is really the driver of emissions, if you like, is that in rough terms, about a third of it is related to the energy that you use to produce the cement, and therefore where you have alternatives, so for example we use quite a bit of biomass and are moving towards also some other alternative fuels next year for the Golden Bay cement plant, which is, I think, the 30% reduction in coal use that Jeff talked about. It will probably get us to a 40% reduction, but that's only a third of the impact. The more difficult 2/3 is that inherent in the process of making cement, the chemical process itself generates carbon. So to get to truly get low carbon cement, you have to work out alternative materials that can give you the same performance but aren't what we typically use to make cement. And that's a technical challenge. It's one, in fact, that we're putting huge amounts of research into at the moment. So the lower carbon, so the reason why locally manufactured cement in New Zealand has lower carbon is because there's of the energy part of the equation, and that's great. But you can only address a third of the carbon emissions through that route, so you actually have to go further. You really have to look at the product, the chemistry of the product itself. So hopefully that wasn't too confusing an explanation. But it derives from using alternative energy mixes to.
Can I just drill down a bit further in that, because I'm really interested in the Fletcher experience here. Do you want to venture a rough idea of time as to when that research might come to fruition? And does that give you an economic opportunity in terms of the technology to create a business out of that internationally? So how's this looking in technical and economic terms?
I would say that the issue with any sort of innovation is the scalability of it, not necessarily the straight technical issues. But I mean, it's active research for us at the moment, and certainly various alternatives exist globally. I wouldn't say they're necessarily large scale. But we have to find something that's relevant to our local environment in terms of the alternative materials you could use.
Thanks.
Perhaps I could
please do.
build on that as well. So for concrete, if you're making it from Portland cement, typically about 70 to 80% of the carbon footprint, as kind of Helen was indicating, is from the cement itself. So most of the impact in concrete is from the cement. It makes up only about 10% of the mass, but a very high part of the carbon footprint. The key reason for Firth's low impact is because the Golden-based cement that they're using has substituted 30% of the coal for biomass, and then they're going to increase that significantly more by using tyres, which may not sound that green a fuel, but when you're substituting coal, tyres actually burn extremely well, and they also contain a portion of natural rubber, which can be considered carbon neutral. So, that's a good news story, but really if you want to bring down the impact of concrete further, you have to be looking at what are called supplementary cementitious materials, so getting the cement out, or at least some of the cement out. So you can actually have material, they're called geopolymer cements that have no actual Portland cement in them. They're made from waste products of the coal industry, for example, like fly ash, and waste products from the steel industry, ground granulated blast furnace slag. And so they use those materials and some additives to create a cement-free concrete. But in the New Zealand context, we have something quite unusual. We don't have a lot of fly ash because we don't have coal power stations. Our cement mill doesn't produce the right type of slag to use. What we do have, though, is an abundance of volcanic ash. And so we have the opportunity to substitute about 30% of our cement with volcanic ash from predominantly the central North Island volcanic plateau. And that's already underway. So both Golden-based cement and HR cement in Tauranga are already actively exploring that technology. It's been used in the past to build some of our dams because it makes incredibly strong concrete. And I think for me that's the greatest opportunity that we have in cement and concrete in New Zealand. And I think that will have a really significant, it'll reduce the carbon footprint by another sort of 25% at a concrete level.
These are encouraging stories because a big dynamic in all of these enormous transformations to a zero carbon economy is the pushback from vested interests, i.e. People have a technology and they're trying to maximize their return on it for as long as possible. So across the panel, what's your sense of how our building material producers here in New Zealand are responding? You've offered some encouraging stories there about innovation, but what's that balance between a real appetite for innovation versus trying to milk the existing technology and assets for all they're worth? Helen needn't answer this question unless she wants to, either personally or on behalf of Fletcher.
I can say that I've been finding it a struggle. Trying to get a manufacturer who's got an existing revenue stream that they rely on, and they've got a existing customer base who's buying that product, trying to get them to abandon that product and sell something else has been a real struggle. Thermally broken windows does my head in every single day. It's a 1/4-inch plastic that's is using 30% of the energy. If we just had a very simple solution, and it just hasn't got market viability for some reason. So yeah, I find it every single day. It's very difficult to get manufacturers to push a new product because it takes away from their existing revenue base.
One opportunity I see is that as a nation we have a lot of aging plant, like manufacturing plants. A lot of them were built in the 50s, 60s, 70s. They're getting old and they have to be replaced. And so I see that as a significant opportunity, but it's kind of like the retrofit point that was brought up before. If you have to do it anyway, you might as well do something kind of great. And so one opportunity we have, is to replace, because when we're talking about embodied emissions, a large proportion of that comes from thermal energy, the stationary heat. So it's from burning natural gas, from burning coal, from whatever it happens to be, to produce the high temperatures needed to manufacture stuff. We also have things in New Zealand like geothermal steam, for example. If we can relocate plant at the right time to make use of that geothermal steam, we can bring our carbon footprint down. If we use things like hydrogen and other alternative fuels produced from electricity, for example, and we do these things at the right time when the plant's being rebuilt anyway, we can then use that opportunity to kind of build in the technology we need. And you can already see that happening. I can't give specific examples because they're confidential, but there are companies, large companies in New Zealand who are looking at new plant and are specifically considering this now and actively choosing where they put their plant to maximise the use of the resources that we have locally, which is very encouraging, I think.
Thanks. Helen?
I think so. to your point, I guess you'd ask yourself, why is this product not necessarily a good product? And it may very well be the energy mix that's used for that product. And I kind of think of them in sort of three tranches, if you like. There's sort of the easily renewable or electrifiable level of energy input to a product where I think most of the low-hanging fruit is probably there, or I think most of the efficiencies are already built in. Then there's sort of a middle tier of sort of medium to low temperature process heat. And now there are more technologies becoming commercially available and at an industrialised scale where you can potentially electrify some of those natural gas sources or coal sources. But then the final problem is really high temperature process heat where there isn't necessarily an alternative, so you're really just trying to look at a source of that heat that's simply lower down the carbon impact scale. So I think it's a mix of solutions because sort of the nature of the manufacturing really determines what solutions are available. But we are talking, primarily about embodied carbon, so in fact the energy that you use to make that is generally going to be a significant source of it. So yeah, working your way sort of up the hierarchy of what can be renewable or electrified, and then if you're into, at this point of time in technology, if you're into a fossil fuel source, thinking of the best one that could be. However, another point is for manufacturers looking at new plant, thinking about what technologies may come on stream in 10 years is also something that we certainly factor into our planning, that something may not be achievable now, but it makes sense to design a new plant in a way that can adopt that technology in a period of time.
Can I just take this one stage further? We've focused this discussion on materials quite heavily in this last little bit around the energy component of that, and making sure that energy is as clean as possible. But is there a greater goal here, that there are some wonderful products out there that we know about or could be coming that are far less polluting, not just in carbon emissions terms, but more sustainable overall, but deliver not only that lower impact at the construction stage, but deliver real operational benefits over the life of the building? Not just on energy, but in other environmental impacts. Is there a real synergy between the nature of that product and the nature of its performance in the building?
I think what you're getting at, or what I interpret it as, or just what I want to say, one of the two. The earlier kind of question about how do we reduce concrete's carbon footprint further is stop using concrete. We've got other materials that can do the same thing or better, but you need a design team, you need a client, you need everyone on board from the start with that in mind. That needs to be a design goal. And if that's not a design goal for your building, if your goal for the building has nothing to do with carbon offsets, you're going to end up with a big, heavy concrete building, which cost more. The big, heavy buildings cost more. We build a lot of 3-story, 4-story, 5-story precast buildings in Auckland, which are really heavy. And when there's an earthquake, heavy buildings take more foundation work to resist those loads. If you have a lighter structure, you have less concrete, you have less cost. So we need to think about the impacts of, yes, we have a different durability criteria we need to think about versus concrete and timber. But there's all these knock-on effects that we're seemingly ignoring. So let's do the best we can to reduce the production part of concrete. You can't replace concrete. It's got its place. But at the same time, if you're building a 4-story building, let's think about, can we do it out of timber? If we're doing a 6-story building, can we do it out of timber? Yes, we can. It's been done the world round.
Well, far higher than 6 stories. And we're planning to plant 1 billion trees. Far too many of them are going to be radiata pine. And that's going to be a useless thing to do if the radiata pine is only shipped offshore as logs to be used for pallets and scaffolding in China, where all that carbon is then re-released. So it seems to me there's this incredible opportunity for New Zealand to take that radiata pine, which is not a great timber in itself, but through engineering solutions, turn it into a building material material that sequesters the carbon, and therefore people who use that should be rewarded for that in some way other than just not being pinged with a carbon emissions tax.
Rod, you set me up perfectly. This is one of my big things. Radiata pine grows so fast here. The problem is once you cut it up and make it into timber, it's pretty lousy to build framing out of. But it's wonderful to manufacture into other things. So it's the perfect building material if you're going to use engineered timber. CLT, glulam, parallel strand timber, any of these products that require extra effort to go into them are in huge demand globally. Huge demand globally. You can't get enough of them. And we're sitting in this climate that is just perfect for it. We've got a tree, like you said, we've planted way too many of, and it'd be a real shame to turn them into pallets 25 years from now. Why don't we turn them into really good, really sensible, very smartly constructed buildings?
So what went wrong in Christchurch that so few buildings were built that way, and the vast majority of the rebuild in Christchurch is tilt slab concrete panels? What went wrong there? How did we lose that fantastic opportunity? How do we make sure we don't lose it again as we continue to build out and renew Auckland and other built environments around the country? What went wrong in Christchurch? How do we stop that happening again?
What I see in the market right now is there's not enough supply to meet the demand for engineered timber. So you don't have the expertise and the designers familiar enough with the timber products. And it's partly this idea that we have to treat every single piece of wood that goes into our buildings to make them durable. We think keeping water out of buildings would be a much better way, and that's what most of the world does. So I think that in order to grow a mass timber industry here, we're going to need to borrow some wood from somewhere else for a while, get used to how we use it, how you design with it, and then slowly over time we start to build some factories, find some places that are doing some mass timber at scale that we can start to take over that kind of industry. So that's what's missing right now, I think, in the market, and that adoption.
Maybe if I could add to that. I mean, we do have a reasonably good engineered timber industry in New Zealand, so we make glulam. We have been making CLT, cross-laminated timber, up until recently, although I think XLAM has closed its plant in Nelson, or is in the process of closing its plant in Nelson and building another one in Australia. Well, they've already built it. So, you know, those products are made here. We've got a very big engineered timber industry, and for those of you who are interested, the Wood Processors and Manufacturers Association will be releasing an environmental product declaration in the next week or so that will cover engineered timber. If you're interested in finding out the kind of impacts of that in the New Zealand context, it will cover all those products. My sort of thought to your question on Christchurch is that it's all about what people are familiar with. You know, in Christchurch there was a lot of pressure to get things done quickly. I know it didn't quite work out that way in the end, and people still kind of felt that it was all too slow. But I think they felt it would be even slower if we introduced new things that people weren't familiar with. And so I think that familiarity, the standardization to the points made earlier around, you know, what's been properly fire tested and fire rated, you know, is it performing to the building code requirements? If it's a new product, has it been properly tested? What is the acoustic performance like? There are so many kind of open questions, and we don't have a lot of experience. That's slowing things down. We do a lot of work with Lend-Lease in Australia, who are building mid-rise timber buildings and looking at their life cycle performance. And I know from talking to them that, you know, it's sort of these building code type requirements, keep making sure that everything ticks all the boxes that's challenging. And they're actually having to import product from Austria and Europe because, you know, it's gone through all the compliance testing, it's a more familiar product, even though there are things manufactured locally that they can't really use because it doesn't tick the boxes yet. So I think there's a bit of a learning curve there, and over the next few years I think that learning curve will move up it quite quickly, and then you might start to see more sort of novel forms of construction, be it timber or other things.
But sticking with the familiar or incremental shift that moves us slightly on from the familiar is a dreadful fate for not just in this, but across all of the enormous transitions and transformations we have to make. So how on earth do we get people beyond the familiar to help them innovate far faster and with greater confidence and greater success in building materials, so we can get some actually transformational change in this? How do we do that?
Science. Innovation is science. It's the practical application of somebody who's come up with an idea put it through some tests, come up with a product. That is innovation. It's science. It's coming up with an idea, testing it, and then building on other ideas from others. So back to my opening kind of statements, until we start trusting the science, innovation becomes very, very difficult.
My feeling is that there will always be a sort of a lead time for innovation, though, in this context. You know, you're building buildings that last 60 years or 90 years or 100 years. We've just come through the leaky building crisis. We can't afford another one. You know, and so we have to be confident in what we're doing. But what we probably can do better from is learning from international experience, because something that's come up before, even when we were chatting as a group earlier, is this very sort of, has it been tested in New Zealand, does it work in New Zealand? And yes, we do have some specific New Zealand conditions, you know, geothermal, where, you know, we've got to deal with seismic performance, we have to deal with the fact we're very coastal and that corrodes a lot of metals, etc., etc. There are some specific things, but we're not completely unique in the world in having those things either. And so I think we probably can learn a lot more from international experience.
And one final thing that will help where it's appropriate is getting back to off-site construction. If you think about it, if you build an entire building element or a component of a building, you can actually test the component, which gives you an ability perhaps to use more innovative materials, because in fact you're testing the performance of potentially an entire floor of a building, an entire structural element. So that may be a way to be more innovative with the materials, because in fact it's the performance of the element that gets tested, regardless of what it was constructed from.
I think the challenge that we do see is that we have innovative ideas. We think we know how they work, but we can't actually explain it to council. So say, hey, this got used in Belgium and worked fantastic. We don't know why, but we like to use it in Auckland for this building. So you go to council and say, hey, we want to do this. It worked over here. And they say, that's fantastic, but we don't have the same building code. So that's the challenge, is the seat that I'm sitting in. There's not very many people that actually can translate what we want to do in new innovative products into a language that complies with the building code. I'm sure you see it all the time. Yeah.
What would help you, Sally, in trying to connect up these drivers and these opportunities from a consents point of view? How do you bridge that gap with Sean?
Sean tells us how to do it. I'm joking a little bit. We do have to assess both the design and the products and systems selected against the relevant clauses of the building code. If you can't tell us how that design is going to perform or that system is going to perform, we can't approve it. In the lower buildings, the under 10 metres, there's a lot of scope around the testing and the appraisals. In the higher buildings, often that information is extrapolated out into how it might perform, and I might receive, or my team might receive, a report from the likes of Sean using his science, looking at the evidence and the test data, and to tell us a very coherent story around how this particular design complies. But I think, and it might lead into some other people's thinking, how can we do this as quickly and as cheaply as possible? And I have to say, when I hear cheap and quick, it worries me about what about the quality. But we work on a time and attendance basis. So the more complete and quality your application is, where you're telling us the story very robustly and aligning it with the building code, the less time we spend on it. We spend a lot of time asking you for information. It either hasn't been supplied, or it's not clear, or it's very generic. It's not specific to your particular development. So all of that stuff provided to us up front really, really drives efficiency, and then it drives costs down.
Thanks. The most popular question, I think, relates very well to this line of discussion we've been having. And the question from Peter is, it's all well and good setting targets for low carbon construction. What incentives or penalties are there for developers to build beyond New Zealand's minimum standards?
I don't think currently at the moment there are. There's certainly not penalties.
No, certainly not penalties. The big incentive by going beyond the building code, or not following the acceptable solution, actually thinking about what you're designing, is it's more likely your building's going to be pretty good. You won't end up in court. That's what we always tell people when we're designing a building is if you're trying to follow a recipe for a single family home to build a 7-story apartment building, it's not going to turn out the way you think it is. We need to actually think about these things and come up with solutions that we know can work and we can prove. So to me, that's the big incentive, is if you spend a bit of extra time looking at better products, looking for more innovation, spending some more time in design, you're less likely to get sued.
Jeff?
I see very few incentives or penalties at the moment. I don't really see much happening in the New Zealand context, but I think there's huge opportunity in that as well because we're starting from a low base. If you look internationally, you see government driving it through public buildings, for example. We will require that all new buildings, so in Germany and France and the UK, all new public buildings over a certain dollar value, €1 million or whatever, require green building certification. They require certain things around having environmental product declarations or embodied energy requirements or whatever it is. And you see that a lot more coming from government and sort of leading by example. You also see it from large corporates specifying they want green buildings because that's where their new corporate head office is. And so if you look even across Australasia, look at Australia, Sydney, Melbourne, etc., where all the sort of CBD real estate, most of that's green building rated. I think office towers have got over 90% coverage, Green Star in Australia, because everyone's competing in that area for the best, most sustainable, nicest place to work, etc., etc. So there's a bit of healthy competition that goes on there in the corporate context. And I think in New Zealand we did have requirements, but some of them have gone away. So there was a requirement within building new schools. There was, I think, 8% historically allocated to green building, and I think that got kind of taken away, is my understanding of it. So there's been a bit of come and go, but there are probably opportunities with whatever Kiwi Build becomes, with large-scale building projects that we could do more.
I got another penalty actually is there's a lot of expensive stuff we do in this country that doesn't add any value to the building. My big one is nogs in walls. There's studies going back to the 70s saying that's not required. It's not required in 3604 framing, yet we still do it. So there's penalties to building the way that we do, is that you're wasting money on things that don't matter.
Thank you. That sounds like a very productive line of questioning to pursue, but I won't, because I'm going to move on through some more of the popular questions from people with us here. Auckland Council has declared a climate emergency. Have there been no tangible moves in the area of building consents in light of this declaration?
You're right, the Council has declared a climate emergency. I referred before about Council's role as a building owner and the steps we're taking. I referred to Council's role as a policy maker and its encouragement of more intense development around public transport hubs. I also referred to our role in our waste program. But Council is a building consenting authority, as a regulator. And we can't just throw the regulation out because we like the idea of sustainability. As I think I also mentioned, we receive an application with literally nothing sustainable about it at all, and it meets the building code and we will approve it, which is why we believe the building code settings set by the central government regulator need to change.
I'm totally hypothetical. I've not thought about this before, but given there's been a declaration of an emergency, if there was identified to be a particular piece of infrastructure or a particular building that was particularly vulnerable to king tide or whatever, and there was a desire for really speedy action on that, would the council, from a consent point of view, fast track that? Or not?
There are provisions under the Building Act for works done under an emergency, and they are essentially legalised afterwards. Consent sought from the building consent manager first, but the actual consent sought after it through the Certificate of Acceptance program. So there definitely are opportunities for genuine emergencies, whether it's coastal inundation. I'm not sure you could describe that as an emergency now where the life and safety of occupants are threatened by that building being in place. So it's a matter of degree.
Okay, thank you. Next most popular question is about limiting waste materials. How do we limit waste materials, of which there can be huge volume, from the actual building construction process? Any takers on that? Because that would indeed help reduce the embodied carbon in such a project.
It's certainly part of it, and to give you some really depressing news, New Zealand performs way below global good or best practice on construction waste. So it's actually a big area for improvement in general. I would say, but because we know that materials lock up a lot of carbon, then clearly waste minimisation is going to reduce the carbon associated with building. However, it's something that we don't really have the incentives to track it particularly well, because it's not really part of generally speaking, it's often something that you don't actually have to report in regulatory terms. So I think there are levers, and whether that's changing the way that waste is dealt with and to require more regulation of it, or so I suppose many of you in the room will probably be familiar with a really successful UK initiative, which was just to increase the waste levy by a certain percentage over a period of time, which let everyone in that industry, for example, know exactly what they were going to have to pay in addition the next year if they didn't reduce their waste. I'm not suggesting that's necessarily the lever for here. I'm more suggesting that we actually don't really have built-in incentives for waste minimisation. So those companies that are doing it and those waste providers that are doing it, many of them doing an excellent job, are really doing that from their own initiative. So I think recognising that it's part of the issue, recognising that there is an embodied carbon component of waste that we're just not seeing, is probably the first stage. But also looking at ourselves critically in the mirror and saying, we pride ourselves on our environmental ethos, and actually we are batting way below average on this particular issue.
I think there's some opportunities in the modular space and the standardization of some typologies. We're definitely seeing a lot more people asking for products coming from the jib factory, for instance, to be made to the length that's required for the building, so that you don't have an offcut that goes to the waste. And a lot of the manufacturers will do these sorts of things for you. You seem to talk to them, or it's understanding that if you order a sliding door wrench slider to 100 mils larger than something else, all of a sudden that creates a waste and something in the background. They have an offcut that they can't use. And so I think there's room in the industry overall to kind of come up with some standardization. Then we can start to say that, hey, we've got windows that are 200 millimeters is kind of the rough opening sizes we have. Then everyone in the industry can start to optimize their supply chains to deliver things in those increments of size. Right now we're ordering for windows is horrendous. We're ordering things to the 1/8 of an inch, which is 3, 4, 5, 6 millimeters. And those get measured on site. So the more we can start to push industry towards standardization, standard floor plans. Housing New Zealand is doing a great job of this on standardizing floor plans. So they have now got some typologies that they're going to roll out around the country. Now all these suppliers can start to gear up and say, hey, we've got this many windows to build of the same size. We can start ordering stuff to match those sizes. So that's a part of this.
Thank you. Actually, Helen, there's a related question from somebody specifically to you. Does New Zealand have skills and capabilities to do modular build? Current examples are all shipped from overseas with cheap labour.
Yes, we do. There's a change in thinking required. You sort of have to take your construction hat off and put your manufacturing hat on, because essentially that's what you're doing. You're manufacturing a very high quality product that performs in a certain way to a specification with the modular construction that we do, the investment we're making. The tolerances are incredibly tight, the accuracy and the quality is incredibly good. So we do actually have that skill set. Maybe when we think about it, we're not seeing the skills, because we have a strong manufacturing sector, so maybe we're not seeing that that ability to do it because we're looking at construction skills. However, one thing I would say in addition to that is, design to standard sizes, Sean's point, modular construction, tight tolerances, but there's a lot less bespoke work associated with that. It's faster to construct, so it actually unlocks a lot of capacity in the sector in and of itself. And I'm absolutely confident that it's a skill set that we can develop.
Thank you.
I'm pretty bullish still on Kiwi Build, despite all of its troubles in the early days. If you think about when government announced the policy of Kiwi Build, I don't want to dwell on Kiwi Build, but what it did is it set up a supply chain where a factory a company could make a business decision to set up a factory to do prefab, knowing that there was orders coming. But that's a 2 to 3 year timeline to set up a factory to actually deliver. So what we're seeing in the market now is, for the first time, these factories that are New Zealand based are now producing those buildings. They're now coming out of the factories. So the 1 and 2 year targets for Kiwi Build may or may not get there. But you look at the 3 year target, I think we're going to eclipse that, because we have these factories now starting to deliver at an incredible scale the country's never seen before. We do still need people to put them together on site. I think that it's not a huge leap from what you normally do. But it is a different way of thinking. You're not a carpenter anymore. You're an assembler. You're putting together a kit of parts on site. So yeah, I think it's coming very quickly, and we'll look back 5-10 years and wonder why we did it any other way.
Sorry.
I was about to say that's an area where our central regulator, MB, is really recognising gaps in the building code, and while they haven't really focused on sustainability, those modern methods of construction like prefabrication are definitely on the agenda.
And I just tiny final point. I would keep your eye on the current and the future infrastructure construction in Auckland to see what this looks like on large scale, because that's a model for major infrastructure investment is to do it as to build it off site. The CRLs and the water view tunnels, I would look at those examples.
The disappearance of the Slido questions is my cue from the organisers that time is up. I will just answer briefly one question there, which was what defines a genuine emergency. In relation to councils declaring climate emergencies, I looked at the Civil Defence Act, and actually a climate emergency fits perfectly within the remit of a Civil Defence Act, because the Civil Defence Act is to cope with unprecedented and unexpected events that existing systems, i.e. business as usual, can't cope with. I think by any definition, current systems can't cope. It is not making material improvement in our chances of responding adequately to climate issues. I would argue there is a real emergency here. Tonight we've only been looking at a very particular part, and it was a very good focus to have on the materials we use, and to some extent how we use them in our buildings. A very big thank you to the panel, to Jeff, to Helen, to Sean and to Sally. A big hand for them, please. Thanks very much indeed. As we found last night, and I know we'll find again tomorrow in Christchurch, these are tremendously complex interlocking issues. And so the enormous challenge we have in a country, but it's around the world, is to find new ways to work on these far faster. My great hope is the Zero Carbon Act will get us going on that, because the Climate Commission will be setting 5-year carbon targets, which will be declining. Government government will have to deliver, have to propose strategy that the Climate Commission deems will make material differences and improvements towards those targets. So I think as a sort of an organising principle, an organising structure, this is the experience of the UK over the last 11 years, where they've significantly decoupled emissions from economic growth and brought about some amazing transformations, such as a 2/3 reduction in the cost of electricity from offshore wind farms, that I'm not trying to pin all my hopes on the Zero Carbon Act, but I think as a way of thinking about these issues will help us to advance on these very complex things in a much more effective way. Just very briefly in closing, you'll have seen from the emails that the Green Building Council has come up with this wonderful idea of not giving COHA to panellists, but thank you hugely for your contributions, but rather making a contribution to a charity that you, the audience, choose. Now, this is winner takes all. As you'll see in the email that you'll get, the three charities are Sustainable Coastlines, Habitat for Humanity and Auckland City Mission. So please do respond to the email that you'll get about that after the event. Please do vote. It is winner take all, so it is quite competitive, but it's all in a very, very good cause. So lastly, just my thank you to the Green Building Council for organising this terrific session, for our panellists, for you, for our hosts here in the Town Hall. Thank you, and I just wish you all the best in your work, and please do enjoy some more networking and refreshments at the back of this concert hall for a short while after this, half an hour or so. Thank you very much indeed. Thank you.